Hello, I'm Nicole.
My name is Jimmy.
And I'm Rehan, and we're going to bring you the time-shifting property of the Fourier transformation. So what the time-shifting property of the Fourier transform states is that if you have a signal x of t and shift it by an amount t0, then the resulting Fourier transform will only be multiplied by e to the negative j omega t0. And now Jimmy will show you the proof for this.
My name is Jimmy. I'm trying to prove this equation of Fourier transform time shift. First, we know s j omega equal interval limit between negative infinity to positive infinity with the equation s of t e exponent negative j omega t dt. Okay, first thing we do, like let s of t equals u of t minus t0. The graph should be look like this. T0 here, and we choose this one should be 1. We know everything before T0 from negative infinity to T0 is amplitude should be 0. And after that, T0 to positive infinity should be 1. Now we try to use the integral to prove this one. Negative infinity to T0. We know amplitude should be 0. Time e exponent negative j omega t dt plus interval T0 to positive infinity. Amplitude 1 time e exponent j omega t dt. Like I said before, this side should become 0 because they have amplitude 0 here. And we don't care about this one, it becomes 0. Done. We only care about this side. Okay? Now we use the integral it. After we derive this, and we have this form, this equation. Negative 1 over j omega e negative j omega t limit between t0 and positive infinity. And then we try to put limit inside this equation. We have like this. E negative j omega t, no, sorry, not omega t, infinity. Subtract e negative j omega t0. We know if we put infinity to this t, actually becomes 0. We don't worry about that. Negative and negative, we have positive sign, only left side. Then we have only e exponent negative j omega t0. Now we pull it. Theta times 6 for its transformer. Compare with the equation of what begin, they are equal. Is it true?
So now we're going to be going over a practice problem in which we're going to let x of t equals e to the negative 2t times u of t. Now, just to note, this function over here is not time shifted. We will do a time shifted version of it later for reference. And so we know that for a regular u of t function, everything before 0 has a value of 0, and everything after 0 has a value of 1. And this knowledge allows us to break up this integral into two parts. So let's start by writing out the whole equation first. You have the integral from negative infinity to positive infinity of e to the negative 2t u of t times your e to the negative j omega t dt. And now we break this up into two integrals. One going from negative infinity to 0 of e to the negative 2t times e to the negative j omega t. And recall that the value of u of t for this area from negative infinity to 0 is 0. So we can stick that in there like that. And we add this to the other limit from 0 to infinity of e to the negative 2t times e to the negative j omega t. And the value of u of t for this limit is 1. So we see that since this is 0, we can just cancel it out. Let's just drop it out, since the integral of 0 is 0. And therefore we'll only be focusing on this side over here. So the integral from 0 to infinity of e to the negative 2t e to the negative j omega t dt can be rewritten as the limit from 0 to infinity of e to the negative t j omega plus 2. Since they're common base, we combine them by putting in their exponent, we just factor out a t dt. Now the integral of that is 1 over negative j omega plus 2 times e to the negative t j omega plus 2 dt, well sorry, not dt, evaluated from 0 to infinity. And so that becomes 1 over negative j omega plus 2 e to the infinity, since anything multiplied by infinity becomes infinity, minus, sorry, negative infinity over here, minus e to the 0. So we see that this drops out to 0, and this becomes a 1. So in the end, you just have a negative 1 over here. And when you multiply by the negative over here, your final x of j omega, your Fourier transform of this function, becomes 1 over j omega plus 2. And now Nicole will be showing you a time-shifted version of this function.
So now we're going to do the time-shifted version of the problem, and we're going to shift it over by 1. So we're going to plug it into the equation from negative infinity to infinity of e to the negative j omega t times our x of t, which is now e to the negative 2 t minus 1 u of t minus 1 dt. And then we can combine these two. So our exponent is going to be negative j omega t minus 2t plus 2. And then we can combine these two. So then our integral will look like this, from negative infinity to infinity of e to the negative t j omega plus 2 times u of t minus 1 dt. And so we see that this is a decaying function, and we already know what u of t minus 1 looks like. For this is 1 here, an amplitude of 1. So now we have to look at the two sections here, from negative infinity to 1, and also from 1 to infinity. And so we can break up the integral from negative infinity to 1 of 0, because everything below 1, everything before 1 here is 0. So 0 times e to the negative t j omega plus 2 dt, plus from 1 to infinity of 1 times e to the negative t j omega plus 2. And then again, we can see that this cancels out. And so we're left with this, where it's of the form the integral of e to the u du is equal to e to the u over du, where our u is equal to negative t j omega plus 2. So du is equal to negative j omega plus 2. And then, so we bring this over there. So we have 1 over negative j omega plus 2 e to the negative t j omega plus 2, and we evaluate that from 1 to infinity. So when we plug that in, it turns into 1 over negative j omega plus 2 times e to the negative infinity minus e to the negative 1 j omega plus 2. And then, so this turns into 0, and we have two negative signs. And so we get 1 over j omega plus 2 e to the negative j omega plus 2. And oh, there's a plus 2 here also. So then this exponent cancels out. It simplifies to e to the negative j omega minus 2 plus 2. So it's just this, and we can compare what we got here from the time shifted to the non-time shifted, and we see that the magnitude is the same, but it's just shifted over by a certain phase.